Okay, so here we are at the end of week 9. Oh my gosh, we're gonna make it. Again, not to jinx us, but I'm actually been very thrilled with this semester progressing forward, so yay. And I'm looking at the back of our syllabus, and we're supposed to be wrapping up circles, which we'll probably do today or on Tuesday. We're getting pretty close. And we had talked a lot last time about the presentation project, right? So I want to come back. Nobody has told me that they had concerns about that or that they couldn't do it. So if you end up with concerns about it, please let me know. But my plan is to switch that to be a recorded video kind of thing. So here are the notes that I had last time about what's due. The homework and construction by hand and the bonus homework were due on Tuesday. Did everybody get your construction by hand homework in? I know there was a little bit of a glitch with the submission folder. I haven't looked to make sure, but nobody having issues? Okay. Cool. The construction project. I have that stuff almost ready to load into D2L, so I decided that's what I'll do is I'll just put it into D2L so everybody has it sitting there in their file. If you're coming to Commerce every day, I'll make a few copies, but I won't make as many as I've been making because it's going to waste. So, but anyway, that will be due in 2 weeks, so it's coming not too fast. The write-ups of the semester project, 11-17. The presentations, we're going to be doing a video instead of a face-to-face, and you can do it there. Jessica, what are we supposed to tell you about today? If anybody had a concern about swapping, instead of doing, the plan was to do I'm sorry, I'm trying to think of the date. On Thursday, the 19th, we were supposed to have the class together and everybody do their presentations, 5 minutes per student, showing us what you guys have been doing for your whole semester long project. Okay. And on Tuesday, we discussed the fact that that's going to be a little difficult with a good chunk of you in Zoomville and just a few people that are not even synchronous with us. They're doing this completely online, basically. And then I've got about 4 to 5 that come on a pretty consistent basis here in Commerce. So it just is very hard to manage that way with a little bit of everything. So instead, we decided that what we would do, unless somebody complained about it, was we would make this into a video recording. And then you can have as many tries as you want to make sure your video looks the way you want it to look and your presentation is golden. And so it's not just a one and done where you're sitting here in class going, dang it, I wish I had said this, or I should have put that in there, those kinds of things. So nobody has said that that's going to be an issue. I can work with people if they need help with some of the technology or this and that. So, okay, no problems. This is just like, I'm good. Yes, Maria.
You had mentioned with the video submissions that you'll do it like in a discussion post thing where we'll share links and stuff. And we'll comment on, you said 5 of them?
At least 5.
When will that be due, that part of it?
So once we start doing this recordings thing, it'll be due on the 20th. I'll just have the discussion board already open. Well, it'll be open so that you can load your thing into there. And then as soon as people start submitting, people can start commenting.
But is the due date to have the 5 at least?
Probably by Thanksgiving, so that we can just be done with it and wrap it up. So that gives you 5 days to watch at least 5 videos, 1 video a day. So, yeah, I think that's plenty to get it done before Thanksgiving. So, yeah, that's my plan. Let me throw that on there just in case. Where are my pens? Oh, I left my pen case in the office. This is not my day. I'm already telling you. It's been fun. So we'll say This loom.com is a nice voiceover
Very, very nice.
app. I really like it. I've used it several times for teaching my class this summer. If I had something that I didn't need to demonstrate, that it was more definitions, vocabulary stuff, it was easy to throw together a PowerPoint and put it up. I liked it. So I'm glad you had some experience with it. So the discussion board. And the nice thing about this, I'll say this also, with me making it this way, I haven't done the discussion board yet, but once I get this created, like if you do your presentation this weekend and you're done, you can just load it and be done. And then as soon as people have stuff loaded, people can start commenting or responding. So at least 5 responses. And I will say, and I didn't mention this the other day, but when I say responses, make sure that your responses are kind to one another. They are as spoken as if you were going to be a teacher, a fellow teacher with this person. They're meaningful. They give appropriate feedback. So it's not just enough to say, hey, great video. You're trying to actually get into the content of what they're doing and give them, oh, I never thought about that. Or, hey, this would be cool if I did such and such. Or that, to have an actual conversation about whatever it is that that person has done for their video.
Do you know if you want those to be maybe like around 100 words or?
Oh. As long I'll know it when I see it. As long as it's meaningful, I don't care. You could be meaningful in 22 words. if you were precise, and that would be fine. So it doesn't have to go for length. It just has to be more than, hey, like your video. So let's make the due date on that, because again, it's all online, so who cares? Wednesday before Thanksgiving. That's the
25th.
Thank you. 6th? Yeah. 5th.
The 27th is Friday, so 26th is Thursday.
You're right. That way we'll just, and if I have it in print, then I can make it on your D2L, so everything matches out. Sometimes weird things happen. Okay, is everybody good with that? No complaints. 25th, yes.
It should be 11:25, not 10:25.
Ah, thanks. Sorry, Samantha.
10:25 is in 3 days.
3 days from now, get it done. No, I'm kidding. Yes, so that's a good point. You have a little over a month. So again, your semester-long project that you had all semester long is due on the 17th. So that's less than a month away. So if you've been putting that off, a couple of you have come to me and said, hey, here's my activities. Do these look good? How do I deal with this? How do I deal with that? If you haven't looked at it, by the way, there is a portion of the write-up where you have to do TEKS, which is Texas Essential Knowledge and Skills. There's a nice website out there that's attached to the TEA, Texas Education Agency, that will hook you up with those, but you'll have to kind of search through them to find the correct grade level and what you're trying to do. So yeah, watch out for that. Don't wait till the last minute to go, what's the key? Yes, ma'am.
Going back to a construction project, you said that's going to be in D2L. Is that
Today. I'll have it up in D2L today.
Is that through GeoGebra?
Yes.
Okay.
Well, it's about half and half. It's about half hand construction and then half GeoGebra. The idea of the project is so that I can do it by hand and see what that looks like, and then I can see how quickly GeoGebra does and how much nicer the software is. I'm sure we're all convinced by now, but just a comparison of, okay, what is it exactly that GeoGebra is doing here? Because, like, for instance, bisecting a segment, you just tell it, I want this segment bisected, and boom, it's done. But what are they really doing? They're really having to do the circle thing that we have to do. It's just that the software can do it so much quicker than we can. So they actually do all the constructions we do. Okay. All right. Yay. Okie dokie. And again, again, if weird stuff happens from that and you have questions, let me know. No worries. What I did with y'all's attendance sheet. Probably sitting with my pins. There's the attendance, or the class list at least. Okay, we have been doing circles for the last couple of days, class periods, and we're going to continue with that. I wanted to, I have a protractor compass somewhere. I wanted to just basically give us a circle and these are going to work with mine. They're huge. Give us a circle and we'll get an example and we'll just go from there. So I'm just going to use my compass real quickly with the center mark. I think if you get into the habit of putting a dot there for the center, it helps because then you've got a really nice reference if you need to draw your radius or a diameter or something like that. So that's what I normally do. So here's my circle. We'll call him circle A. And we had definitions of chord and all that kind of stuff. So I'm going to give you one of these. It's going to be, we've talked a little bit about angles. We had inscribed angles the other day, if y'all will remember. This one is actually an angle whose vertex is at the center. I don't remember if we got that definition or not. I want them to not look like they're on the same diameter. Almost look like they are, but I think you can tell it's not quite straight. Okay, so this one's angle, the vertex is actually at the center. Did we get a name for that kind of angle? Central angle. Okay, so I don't remember if we actually put that or not, but this guy is both of these are central angles because their vertex is on the center, central.
We did.
We did? Okay, good. All right, so what I'm going to do is I'm going to say, hey, look, these guys right here are congruent. Even though maybe my picture doesn't look the best. Those angles are congruent. So what do you think about the chord that connects right here and right here?
Also congruent,
Why?
because we have side angle side,
Ah, why do you have side angle side?
because each one of the legs of the now triangle is a radius, which is the same.
Excellent. So I'm hearing from Maria, each of these is a radius. They're radius of the radii of the circle, but they are also the legs of the triangle. They are all congruent. We already have established that. And now she says inside of this triangle, she has side angle side, which is a triangle congruency. So therefore, we know CP, CTC. You don't know that one yet. You've got to learn it. Congruent, I'm sorry. Kind of not on the picture. Corresponding parts of congruent triangles are congruent, right? So we know that these guys out here are congruent to each other. Now, they're not necessarily congruent to the legs, right? But they are congruent to one another. So I'm going to give them 2 hash marks instead of 1. It's possible for me to construct an equilateral triangle in here. I just don't know that I did. Okay, till I have more information. But for sure we have 2 isosceles triangles. Does everybody agree with that? Okay. And then, so we've got this thing going on that says, okay, if I have a central angle, then the chords that are opposite those central angles are congruent. Just automatically. It's one of your properties that's in your book. We also discussed the fact the other day, I think it was last Thursday, that these outer arcs are also congruent. And basically it's because we have a sector that's congruent to another sector, so their arcs are going to be congruent, okay? So we're not necessarily proving that. I'm going to put like a little lightning bolt on that guy because he's really close to the other one. But we talked about that last week, right? That those arcs are going to be congruent, okay? So there are some other properties in your book, and I just want to kind of leaf through them and make sure we've got some stuff. So how about this? How far do you think the congruent arcs are from the center? Any point on the arc, like if I pick this distance out here,
It's gonna be the length of the radius.
good, it's going to be the length of the radius, out here, out here. It doesn't matter. At any point in that arc, it's going to be the same distance. So those are equidistant, okay? What did I do? Oh, this one's so much fun. Not. Okay, so you've got this stuff that says two congruent chords in a circle are equidistant from the center of the circle. Okay, that makes sense. If two chords in a circle are congruent, then they're, so think about it, it's like the opposite. So let me get some letters out here. B, C, D, and E. So we know that BC is congruent to DE and that they're chords. Does everybody agree with that? So think about it the opposite direction. If you have two chords and they're congruent, then what do you know about the angles that they came from?
They're also congruent.
They're also congruent, right? So you can kind of backtrack and say this gives me congruent central angles. Okay. So for instance, if we're working a problem and we know something about these guys out here, but we don't know anything about their central angles, well, we can work backwards and say it's okay because it would be the converse. We've got that. These chords are congruent, so the angles are congruent. Okay, so that one's in your book. That's awesome. If two chords in a circle are congruent, then they determine two central angles that are congruent. That's the way they word it. Okay, this one's a little weird, so I'm going to draw a new picture. It says, so let's call this circle F. Draw a perpendicular from the center of a circle to a chord. Okay, so pick a chord. It doesn't matter where. I think I'm going to put mine kind of on the left-hand side and chop up I just want a bigger section cut off here because I want to be able to really see what's going on in the picture. Okay. So if we create a perpendicular from the center of the circle to a chord, any chord, it doesn't matter where it is, then, and we're going to figure out what. Okay. Now we could construct this guy and force it to be perpendicular, but I really don't want to go through that hassle. And we can kind of eyeball it. I think we'll all be okay. If I want to make a perpendicular to this chord from the center, is that going to do it? No, because it's coming way too high, right? And so I also don't want to make the perpendicular like this. So I want to make sure that the angle is as close to 90 degrees as I can. And again, we could do that if we constructed it. Oops. There we go. Okay, so that looks about 90 degrees to me. Close as I'm probably going to manually get. So there we go. We're going to say it is. Okay, then what do we think about what we've done?
Have we bisected the chord?
Yes. Then we bisect the chord. Okay. And there's ways for us to show that. And chord is bisector. Okay. Because if I hit it way up here, I would have a little piece and a long piece, right? If I hit it way down there, I'd have a long piece with a little piece. So as I kind of narrow in on the 90 degrees, it kind of sandwiches, if you will, from a calculus concept, kind of sandwiches between them, and it ends up being the perpendicular is the perpendicular bisector. Okay, so let's see if we can figure that out. I would say 80% of the time, I'm just throwing a number out there. 80% of the time, if you want to figure out something dealing with circles and you want to prove it, you want to show it, then probably go to a triangle would be my guess, because we're going to have some similar stuff going on here. So let us do this. Maybe it helps us, maybe it doesn't, but I'm going to try to. I'm going to construct the radius that goes from the center to the one endpoint of this chord. Let's call him FGH, chord GH. Okay. And I said construct. I'm really just drawing, right? In order to construct, I'd have to, you know, do the whole straight edge and compass thing. I'm just straight edging right now. It's not precise. Uh-oh. Question about the 17 copies. Oh, okay, Ryan. So since that's a good question, I'm sorry. Sidebar. I don't know how long this question's been sitting here. Sorry, guys. Ryan has a question about the 17 copies that we were originally going to bring for our projects, the write-ups and the activities. So since we're doing it all on video, you won't need to make any copies. It's a great question. Sorry. If it's been sitting there a while, I'm sorry. It'll all be done video-wise. Yeah. Okay. What do we think? Does it help us or hurt us, or we don't know?
We have side angle side
Where?
with the radius with GF, and then we have
side, side, side. Or both.
How?
So GF is radius, and so is FH, so those are congruent. And then we know that we bisected the chord, so.
We don't know that. That's what we're trying to prove.
Oh, okay.
Dang it. But once we have that, we'll for sure have side, side,
We
side.
have the same segment in between the two triangles. So
This segment is congruent to itself.
Are we allowed that 90-degree angle?
Yes, because we're starting with that. So it is a perpendicular for sure. So we've got side, side angle, which is not a congruency, triangle congruency. But side, side angle in this case tells me I'm probably pretty close. I can't do side, side, side because that's what I'm trying to prove is the chord is bisected. So I'm probably needing some side angle side, right? Or just any angle, actually. If I could get any of the other two angles, then I'd have angle, angle, and then some other whatever, and I'd be okay.
Are we allowed the angle F
Why? What do you want to allow it?
to be congruent? Because be allowed to say that we split that angle, like angle GFH, the radius is coming through it?
Sure would be nice if we've just bisected this angle too, wouldn't it?
No.
That's what Miss Ashley's telling me. So it comes down to, can I show that? Let me copy this just a little bit, make it a little bigger. It looks like, that's terrible. Here. It looks like this. just trying to make it a bigger picture. I knew I needed a bigger circle. Okay, it looks like that. And what I'm hearing is if we can say that this guy right here has been bisected, then we'll have side angle side, because this guy's congruent to himself. And that would be lovely. So what do we know about bisecting angles? How did that happen? How do we bisect angles? Using our compass and straight edge. Or GeoGebra. How do they do that? If you'll remember, they do this. Oops. It would help if I... No, I think that's right. They make the circle from one, and then they make the circle from the other. Yeah, okay. It just looked weird because I'm going vertical instead of side to side. And then they what? See where they intersect and see where they intersect. Now this, I hand drew this, so it's probably not going to be exact. So, but it's not bad. Hey, you did a pretty good job, actually. Not bad. It was my 90 degrees. Well, actually, that's a little bit off, but anyway. So we do that, and we connect the intersections, and we say that guy has been bisected, and what?
The angles are congruent.
I'm sorry, I just made a perpendicular, didn't I? Yeah, those angles are perpendicular. So I actually need to be not paying attention to this one. Yes, this one has been bisected. I actually, man. I need my regular pins. They're just going in them. Now I'm kind of stuck. G, F, H. I was creating the perpendicular. I did a pretty good job the first time with perpendicular. Here we go. To bisect this guy, make an arc, right? And then what? Take the measurement from one side to the other side. Make an arc. Use the same hole. From one side to the other side. And this. And then connect. This piece is congruent to that piece. So look at what I've done, and can we justify that that is actually bisecting here? What we would need is for our arc here to come across here like this. And then we build it from there. What do we think about that? We're not sure. Okay, so we're gonna put a hold on that. I would say that we have bisected that angle, and we're gonna have to argue later for how we know and why. Okay, it's gonna be one of our proofs, so it'll be okay. So for right now, the property, the conjecture, hasn't been proven, so it's not a theory. So the conjecture right now is that this is what's happening. We bisected it. We're just going to have to do something to prove to ourselves that this is true. And maybe it comes down to some other kind of triangle. Maybe this triangle isn't helping us. But we'll show it later if we need to. I think we'll see if this is what's happening. Think about it. All right, what other conjectures do we have in our book? Perpendicular bisector of a chord conjecture. The perpendicular bisector of a chord passes through the center of the circle. So this is actually the opposite, the converse, basically. If you have a perpendicular and it bisects that chord, then it must be going through the center. It can't be this perpendicular down here. That perpendicular down there doesn't bisect it. So if it bisects it and it's perpendicular, it had to go through the center. So that's the backwards, the converse of it. Okay. So there's some chord stuff. I'm not really thrilled about the chords pieces because I don't feel like they're that terribly important. The ones that come in handy, some of them come in handy, but the ones that really come in handy are normally more of the tangent ones. I'm gonna draw me a new circle. The tangent ones and the arc ones, those I tend to use, I feel like, oh my goodness, a lot more. Human error. Get over there. Okay. There we go. All right, we're up to H. Let's do I. What does tangent mean?
Touching.
Next to, touching, up against. If you're tangent to me, you're probably pretty close in my space. Okay, nowadays. A tangent line is one that barely touches, in this case, your circle. Okay, barely touches your circle. Okay, and in fact, whenever I teach calculus, I talk about how tangent lines just come up to and just barely bounce off of almost. So for instance, if we were doing a parabola and we wanted to draw a line through it or up to it, if I drew one that looked like this, that's not a tangent line. In fact, that, anybody? Are y'all in 361? Have y'all seen this?
I think we're quite there yet.
Okay, it's coming. So this will pay off in your other class as well. So this one, it touches in two different spots. It's a secant line. S-E-C-A-N-T, secant line, okay? And I can find the average rate of change between those if I'm in your calculus class. It's basically a slope of a line, right? So no big deal there. However, if I keep on coming down and I put a line here and it just barely hits the parabola in one spot, that's what I'm talking about. It's a tangent. It just barely grazes up against your parabola. So it's a tangent line, okay? The problem with that one is if I want to know his slope, it's very hard to do because I only have one point on the parabola. Does that make sense? So that's where your calculus skills are going to come in, and you're going to take limits and lovely things like that. It'll be fun. But the idea being that the whole concept for taking a limit and for finding this guy a derivative later is that I'm going to just continue to take that secant line and make it closer and closer and closer to this point until basically there's nothing left but just a negligible difference between the 2 points. So in other words, there could be another secant line down here. And of course, my picture's really getting small. But you can tell the difference between these 2 points is less than the difference between those 2 points was, right? So you just keep on getting them until those differences are smaller and smaller and smaller until we go, it's basically nothing. So it's basically a tangent, okay? So this idea of a tangent line, you kind of need to have that idea of what it is, just barely going to graze off to be able to talk about a tangent to this guy. So for instance, I'm going to put a radius on this. It's going to come out here to this point right here. And then I'm going to draw a tangent line on it. And basically the idea being that I'm just going to barely graze that one point where the radius comes out to the edge of the circle. Barely graze it. So this one goes like this. A tangent to a circle, and we want to find out does something to the radius that is drawn to that point. And they call it the point of tangency. We don't need that word. Okay. Just draw a radius that actually meets up with that tangent line. That's what they mean. And then what do you think that tangent is compared to the radius? Looks perpendicular. Right? Absolutely. Okay. So basically what we're saying is we're creating, if we make the tangent line and we make a radius, then we're creating a 90-degree angle there. Which is going to pay off for us whenever I do really big triangles on this thing. For instance, what if I had another radius coming down from that guy instead of going up? And I'm going to slightly tilt him. And I have another tangent like this. Going to, again, that one point. Okay, well, if we can assume that that's true, and we'll show it later, if we can assume that that makes a 90-degree angle, and I look at that picture, and I think, oh my gosh, it looks like a, anybody? What's that quadrilateral look like? It's the green.
Kite.
Looks like a kite. Yeah, the green part, right? So I've got Christmas colors here today. I don't know why. These are the markers I have. Can we show that it's a kite?
We know that the radius are congruent.
Okay, the radii are congruent. I like that. What did we do with almost all of our quadrilaterals when we wanted to prove something about them?
Triangles.
Made them into triangles, right? Let's do it. That would be this line that goes right down the middle. Oops. Hi, man. Angle bad. Let's see, get it going. Okay, that guy right there. Well, what do we know about that guy that goes right down the middle? He's in both triangles, right? He's congruent to himself, absolutely. So we'll put the little lightning bolt thingy on there. Now this one might help us with the last one we did. What do we know about kites? Oh, it has another diagonal. Okay. Let's get him on there. It goes from these two non-vertex angles, right? It is a chord in the circle. So you see how everything we've done starts like fitting together and working out for us? Awesome. Okay, so what do we know about the diagonals and all that for a kite?
They're perpendicular.
Okay, they are perpendicular. That looks almost exactly like what we just did.
And the chord now is bisected
And why do we know that?
because of the kite properties.
Because the kite property says that the longer the vertex diagonal bisects the non-vertex diagonal. Does everybody agree? Remember that? Oh, we just proved what we wanted to prove a second ago. Yes, I love that. Okay, and then what else do we know about that guy? Look at,
Side angle side, we have the same segment and then the 90-degree angle at the two diagonals. And then the chord is bisected. Of the larger.
here,
Then the larger triangles.
here?
Yes.
Okay, so if I have side angle side, she says, then this piece right here and this piece are congruent. Okay, those two legs. And that's actually the conjecture that the book is getting towards. So we'll see that in a second, that those tangent lines from wherever they intersected out here to wherever they created this 90-degree angle, they're congruent. Okay, so that's what Maria just said. So I'm gonna stick 3 congruency lines on that. Okay. And then because of that, we know a whole bunch of other stuff, right? So inside of this triangle, every piece of it is congruent. I was thinking we would actually get to the kite property where it says that this non-vertex or diagonal does what to these angles up here? Bisects them, which is what we were trying to show earlier, right? You knew it was there. She's like, I know it's there. I just can't quite see it. It's because we didn't have
The rest of the picture.
the other piece of our kite, right? We were missing a piece. So now we see it. Obviously, it's obvious now, but it wasn't before, right? So now you can say all of these pieces are congruent. These are definitely bisected. I can give them a 1 mark, and these are definitely bisected. I can give them a 2 mark. Okay, and now all of my triangles better be congruent, right? So I can look at all the little pieces. So Maria was looking at these larger 2 right here. We could also look at these smaller 2, and we've certainly got, I didn't mark this guy, but if I just look at that little piece there, he's congruent to himself, right? So side angle side or side or whatever at this point, you can do them all. And I can look at the whole big, huge triangle, right? And I can now talk about these central angles that we created, right? And the fact that they're congruent on this bigger, huge triangle. Awesome. So we see it. We just needed 1 more piece with our kites. So the triangles helped us. It just didn't quite get us where we wanted to go. And then look, a quadrilateral saves the day. It's amazing. So this one says, this conjecture in your book, and actually we haven't proven it yet, but we see it. We for sure got the steps that we would need to take. Says, uh-oh. If 2 tangent lines intersect outside a circle, 2 tangent lines, I should say to the circle. Sorry, they got to be tangent to something. 2 tangent lines to the circle intersect outside a circle. And they form perpendicular angles with radii of the circle. So both of those have to happen. In other words, they have to meet somewhere out here. They have to be tangent to this thing and make a 90-degree angle, right? Both of those work. Okay. So if we have those 2 conditions, then what? Then the tangents are congruent. Absolutely. Tangents are congruent.
If 2 tangent lines.
To the circle
Okay.
They're tangent lines to the circle, and they intersect outside of the circle. And they form perpendicular angles with the radii to the circle, whatever. And those tangent lines are congruent. Okay.
Do we not need to specify that it's from the intersection point to the point where they create?
Yeah,
the
I'm being lazy.
I was just curious about that, because obviously you can make that tangent line as long as you
Yeah.
want it, and that would be.
I could probably say line segments and be done with it. From intersection to intersection, basically is what I'm saying there. Yep, absolutely. The segment portion of them, not the entire line. You're correct. I'm just being lazy. I didn't want to, but you made me. That's okay. Here, this is the way it's worded in the book. Page 314, it says, tangent segments, see, they use segments and it makes it life easier, to a circle from a point outside of the circle are congruent. Yeah. So tangent segments, that's what these would be. Let's put some letters on them. I can't believe we went through that whole thing, you know, it makes me put in letters. J, K, and L. So the tangent segment JK and the tangent segment JL, they are forming perpendiculars. They are congruent. That's what we're saying. Absolutely. It's on page 314 of your book if you want to find it. Tangent segments to a circle from a point outside the circle are congruent. Yeah. Well, 314 of my version of the book. It's close to that, I think. All right. Yay. So those are the two really big tangent ones. And so what I'd like to do is do a little bit of work with it and do some problems and see if we can do some of the homeworky things. This particular homework is going to be one of those handouts that I've got. So you should be safe. Everybody have the same stuff. Be all right. Okay. Here we go. We have this picture with a circle. They call it circle Q. And then they have array they call R. An array they call S. And they meet here and here, and they form a chord. And there's a point out here, T, U, and B. And we know that this guy is 70 degrees. So the question is, can we figure out what this angle is? And they call it X. Now, notice it is not the angle that goes between the chord and the circle. And the reason for that is the same thing that we talked about last week. We're normally not going to have an angle or any kind of a thing where we're measuring the degrees and one of the pieces is a curve, right? So they go all the way out to the tangent segment that they're calling TV. Ooh, TV. Hey, you gotta take pleasure where you can get it. All right. What do we think?
Are we allowed to bisect the 70 degrees, creating a perpendicular to the UV center? 90 plus 35 minus 180 equals X.
You could do that. Absolutely. All right, so the idea I have here in Commerce is, let's go ahead and bisect this guy. Look at what interesting thing happens when I do that. When we do that, we're making a perpendicular here. You wanted to bisect this chord, perpendicular bisector. It's actually using one of those other properties that we had, right? So we can do that. She's saying that this guy is now 35 degrees and 35 degrees. Isn't that what you said? I think that's what she said. She said 180 degrees minus 90 degrees gives her 90 degrees, minus 35 degrees gives her 55 degrees. Everybody agree? Okay, so that's this guy over here. I want to take this a little bit farther because I realize that my definition and the book's definition don't quite add up. So I want to make sure we're all on the same page here. For that last conjecture, I want to make sure we're all on the same page because I was more specific than they were. So I want to make sure we're all together. The center was way over here. That chord does not go through the center. Mine went through the center, right? So we want to make sure that everything works out for us okay. So that guy's 55 degrees. What about the other angle up here, TUQ?
You would subtract the same thing and also get 55, but with the large triangle, it doesn't, oh, never mind, it does.
We'll check it, right? We'll make sure. Okay, so this guy here, again, the bigger angle, is also 55 degrees because what we've done is we've created two congruent triangles here, right? We could go ahead and throw in the extra piece for the kite, right? We know that that guy's out there. Oops. Yeah, make sure I don't have the same congruency markers anywhere else. Okay, we could go ahead and throw that one in. Okay. So then Maria says, wait, let's check the big triangle because we want to make sure, right? Absolutely we do. So we're using this big angle here, which is 70 degrees. And we're using this big angle here, which is 55 degrees. And we're using this big angle here, which is 55 degrees. So when I add this together, that should be 110 plus the 70 is 180. So all of our math is working out. We like it when that happens. Hopefully we don't do anything weird and crazy. So basically what we've just shown is that these guys, well, we didn't show it, but it's one more step out there. We're still creating a kite, aren't we? We didn't do it on purpose, but we're still basically creating a kite. And because these two triangles are congruent, we've still got this piece out here. I'll put 3 on him. Is congruent to that piece out there. But they don't have the more specific piece that I had. I had that we needed a perpendicular, right? So when I read their thing in the book, it said, it didn't say perpendicular. It says tangent segments to a circle from the same point outside the circle are congruent. So what they're saying is if you start here at a point outside the circle and you draw those tangent segments, it doesn't matter if they're perpendicular. Okay. Now they will be perpendicular if it's a radius, right? Which is the one that I was doing. But this one happens to be a chord and they're not perpendicular and the segments are still congruent, the tangent segments, right? Okay. So that's kind of nice to know. It doesn't have to be as specific as what I was making it. So, whoop. Nice. Any of those tangents. And you might be like, but why? What if I moved my point? It doesn't matter, right? So if I move my point, to be, let's call this guy, what are we up to? U. Okay. If I move my point anywhere around the circle, let's say we put it over here, the point that's off the circle where the two tangents intersect, and then I create the tangent, just the fact that this point, I'm coming from the same point to make this other tangent. Look at that. It doesn't matter where I shift it. And basically what we're dealing with here is the fact that this guy out here is on a circle also, right? So that distance to the intersection to the center, if we use the same center, which is what we would do, it's basically the same distance for the radius, no matter where the point is, which is kind of cool. Okay. There we are. That was actually a homework question. And yes, the answer is 55. Very nice. Let's do another one. Oh, y'all can figure this one out. This one's almost too easy. I don't know. We'll see. He's got a circle. They call it Circle R. And they have a diameter going through it, straight up and down, all the way through it. It's extended. And then they've got this point out here, outside of the circle, that creates a tangent line. Okay. Yep. They call this ray K. They don't even give this guy a name. They create the radius that is tangent to that guy. Mm-hmm. And they tell you that this angle out here is 120 degrees. Yep, that's what they give you. And then they say, how big is this angle out here?
Well, we know that that interior angle above the 120 is 60 degrees.
Okay.
They live near pairs.
Everybody agree? They have to be, they're a linear pair.
Don't we know
Okay.
that the radius and the tangent are perpendicular?
Yep.
So now we have two of the angles, and y would equal 30.
Mm-hmm. Because this is a radius and because that guy's tangent at the same point, that has to be 90 degrees. And now we have a triangle that adds up to 180 degrees, so we can find y. There we agree? So I was like, this one's too easy for you guys. 30 degrees. Okay. If you didn't see it right there, or if like you didn't get this 90-degree guy here, you could have done something else. You could have created the kite, right? You could have come this way with it and finished it out. Because they're just giving me the diagonal for the kite going through the center and 1/2 of it, right? But you could have done this. And remember, if our math is good, every rule we know should always work, right? If it's something we've got. So then, oh, this shows me actually a really cool thing that's going on. You see that 120 degrees on the bottom? What do you think about this 120 degrees here? Or I'm sorry, this angle here? It's probably 120 degrees, right? So, and we can show that with the whole kite thing. This guy's got to be 60 degrees as well. This guy's got to be 120. The big angle here in the kite would have to be 120, but once I've bisected it like that with the diagonal, 60, 60, okay. And then we could talk about, even if we don't know that this is 90 degrees, we could talk about the angles of the quadrilateral, right? So this is 120. This is 2y. This is 2 of something, right? We happen to know it's 90 degrees. And then figure out that that's got to equal 540, 360, 360 degrees. Yeah, there we go. Okay. I think you would have to break it into, I think if you're going to do that, you'd have to know that that was 90 degrees, or you'd have to go ahead and break it into this other diagonal and use all your congruent triangle pieces. All right. Are we doing all right? Nobody's screaming. Zoomville has been very quiet the last few days. Okay, so there's some other properties. I'm feeling brain dead. I think y'all are probably brain dead. I'm getting a lot of quietness. So we will work on some other properties. It'll be fine. For instance, we know, or we will know, that whenever we compare the angle, oh, let me just throw this picture out there. Let me give you a brain teaser and see how y'all do. That was nasty. God, it's not a video of me. What I'm doing here. It's crazy. All right, I'm going to do this while I take roll. Say that you have a circle. This is one for the road. And what I'll do is the 2 things that I want you to do from today's class are the construction project. Oh, goodness. Group. Almost there. I'll finish it up and make sure it's loaded up into D2L, finished out. And then the homework for 6.1 and 6.2. So I'll get those loaded up as well. Okay, here, y'all think about this one while I take roll. If you have a central angle, call him angle ABC or CAB, CAB. And then you have an inscribed angle. I'm going to give you a couple of them. Let's make one over here. They're going to use the same endpoints as CAB. But they're inscribed, which means that all the vertices and endpoints are on the circle. Remember that? That's inscribed. Let's do another one. Let's do this guy over here. He's actually going to go through the middle of the circle, of the angle. What I'd like you to do is think about a relationship between the central and the inscribed angles. Okay, so CAB, the central angle versus the inscribed angles, they have to share the same endpoints. And I'm going to call roll. If you don't get it, you just take it home and think about it. All right. Okay. Lost somebody. I heard them ding off. So, Samantha's here. Maria's here. Christina's here. I don't see Gabriel. I don't see Alexis. Jessica's here, Summer's here. It was Matt. Left already. Carolyn's not here, Demondre's in class. Elijah, I see you. Amberly. Ashley's here in commerce, Mary. And Ryan. I don't see Garrett and I don't see Kane. What do y'all think?
Angles are congruent.
Which ones?
The BDC, BAC, and BEC.
Oh, I didn't know. So Summer thinks that some of these angles are congruent. I'm gonna not give all of that. Maria, did you have a thought?
No, I have the same question that Mary
Oh.
has. You said the construction homework or project and the 6162 homework?
Yeah, I'll load those into D2L. They're not there yet, but I'll get them up there today so that they're there. It's 2 handouts, basically. 6.1 and 6.2.
When is that due?
1 week
From today?
from today. Here's my thing. Point 1 and 6.2 handouts. And 29.
Yeah.
Yep. Almost Halloween. Almost the holiday season. It's gonna go crazy. Okay, so I'm gonna give Summer, she says that she thinks that the inscribed angles are congruent. Okay, and I'm gonna let y'all think about that. So she was saying it doesn't matter, like I could do another inscribed angle way over here, but as long as the endpoints are the same, we think those angles would be congruent. I want y'all to think about that. And then compare it to the central angle, which I think is bigger. That's my hint for you. Okay, so think about that. If you need to, you can take it home and maybe make some triangles or something like that and play with it. But I am out of time for the day, so there we go. Ryan, I think I answered your question. We're not doing copies if we do video. Okay. All right, that's it. I took roll. We're done for the day, done for the week, week 9. Yay. Have a lovely weekend. I'll get stuff uploaded.
See you Tuesday. Thank you.
Take care. Not yet, Mary. With the dates. Can you see the homework page with the dates? Oh, I don't even have that with me. I'm sorry. It's going to look a lot like, here, let me stop the recording. Thanks. Have a good weekend.